Hello there, ladies and gentlemen. My name is Parker, and welcome to Parker Programs. Today, we're going to be tackling problem 5 of Project Euler. So I'm just going to read this out for us so that we all know what's going on. 2,520 is the smallest number that can be divided by each of the numbers from 1 to 10 without any remainder. What is the smallest positive number that is evenly divisible by all of the numbers from 1 to 20? I'm guessing evenly divisible just simply means that it can be done without any remainder. So that's what we're going to go through and try and figure out. So let's hop over to our code. I'll just quickly comment this one out. And once again, we're going to do the exact same thing. We are going to right click here, and we are going to add a new item, new class, which we are just going to call the, let's just call it evenly divisible. Hasn't registered the E. There we go. And we'll just add that in. And then it should do some magic stuff. And here we are. Fantastic. So, as always, we are going to do a public static void, which we are just going to call execute. It's going to run our program as always. And here we are. So, what we need to do is figure out which lowest number is evenly divisible by 1 through to 20. So immediately what that means is that we can sort of get rid of any number that is below 20, because any number below 20 won't be able to be divided by 20 evenly. So I'm just going to quickly do this in a while loop, because we don't actually know the number, so we are trying to get to a specific point. So while just true, because we're just going to keep running this until time galore and everything dies. We are going to have an integer, which I am going to call the final value, which by default is just going to be equal to 0. And then we are going to say, so, while true, we need a counter as well. So int counter is equal to, well, we're going to start it at 20 because we don't need to actually check anything below 20. So, while true, we are going to do for int I is equal to 1. Let's just check this. I don't believe it was counting 0. From 1 to 10. Bingo. Okay. So, for I equals 1, I is less than or equal to 20. I plus plus. We are going to try and increment and check to see if it needs to be added as our final value. So, how can we go about this? We are going to have to break out of this loop at some point after making this counter work. We can just break out a for if we find one that doesn't. So, for this int I is something we are going to do. Let's see. If we just create another integer number, which by default is going to be equal to 0. Actually, we'll need to make this a float, just because we're going to be doing division, and we need to get it into a float variable, because that way, if it's uneven, then we're good. So, if counter remainder I is not equal to 0, this should actually be in an if statement. So if counter thingy I is not equal to 0, then we break. When we come out, we need to increase counter by 1. Or plus plus. This is just a nice shorthand way of incrementing. Counter plus plus break. So this is just saying if this dies, we are going to break. And I just realized that's actually going to break out of our for loop. So this counter wouldn't be called, and so we need to actually just put this at the end of our while loop instead. Just going to be here. Bingo. So if list divisible by 1 is not equal to 0, then we break. Otherwise, thing is, if we just fall out of lists, we're not catching why we're breaking out of lists. So this is just going through, and this is just keeping track of lists, and then we die. Okay, let's just do it the good old-fashioned way in a boolean. We'll call. Oh God, what do we call it? I'm just gonna call it is working. Stupid variable name, but hey, let's go with it. That means we don't actually need to keep track of list number. So if this is it, if we say is working is equal to false. Actually, let's set this to true by default because we're inverting it and telling it that it's false here. So it's working, it's true, it's working is equal to false. And then when we get to the bottom of here, we say if is working. Oh, actually, I went wrong side of the bracket there. So if it is working, then we need to. There we go. I'll just quickly bring this back in line. So if it is working, we then check. Well, actually, no, if it is working, then we know that's the right value. At which case, we can just sort of say the final value is equal to our counter. And then we break out of list loop, which means that we are now out. So while true, break. And let's just go here, and we'll just say console write line. Highest num is equal to where am I? Oh yeah, it's equal to the highest num. Or final value even. Should have called them highest num. Oh well. Okay, so that should work. The only issue I can think with this program is that if the counter tries to go above the highest value of an integer, then we're going to have problems. But I don't think we're going to get that far, so let's just give this a try and see what answer we get. So, we are going to go evenly divisible dot execute. And just save that. So, let's try giving this a run and see what answer we get. And it's building, and it's running. Okay, this looks like it's going to take a while, so I'm just going to cut here. I'll be back when it's finished. Okay, so I just killed the program. It didn't actually find the answer. The reason I've done it is because it's difficult to actually tell if this is sort of running and if this is working. So what I'm going to do is I'm going to put in another few console.write lines just so we can actually see the program running. So what I'm going to do is I am just going to, in here, I'm going to just say console write line processed value, and then we are just going to add on the counter value. This way when it's running, we should be able to see that it's processing each value independent. There you go, see? Fantastic. So now that this is running and we are 100% certain of that, I'll be back when it's finished. I just was running this for a while. I put in this is working console write line to see what was happening, and this is the point where I just realized I made a very, very, very simple rookie error. I've put is working as equal to false. When we increment the counter, we don't ever actually set it back to true, so it's always going to be permanently false. So let's try this again. So is working needs to be set back to true. True. And now hopefully it should run and we should be able to get a value. And it'll process all the values. And as I say, I'll be back when it finally finds a value that works. Okay, so this is actually taking a while. So what I'm going to do is I'm going to kill the program, and I'm just going to change this to be more than or equal to 10. And the reason I'm going to do this is because we know, and the counter can say the same, because we know that the value is higher than that. Okay, So what we can do is we can run through this and we can check to see if this algorithm is working, because we actually have the answer from Project Euler. We have the answer is 2,520. Okay, so let's just run this through again, and if we get that answer, then we know this program's working. There we go. Okay, so we know the program is definitely working. We know that the whole function is doing exactly as it should. So it just means that that value is very, very high. So I'm just going to set this off, and then we're definitely 100% going to recheck this and make sure that it is 100% working. And we should hopefully get a value. I'd left that program running for about 4 minutes there, hence why I'm not showing you it all, and I will be back when that program is finished figuring out what the answer is for every number between 1 and 20. Hey, okay, so what's happened is that I ran through the program. I thought I was recording it previously, but turns out I wasn't. Basically, I ran the program. It took quite a time. It took 40 odd minutes or so, I guess. But this is the answer that I got in the end, is 2327956, which, as you can see, I've put it in the Project Euler. We have got the correct answer. I mean, the one way that I thought to optimize this program is to just do increments of 20. That's the highest multiple that we have that we need to check, and therefore we could skip out checking a lot of these numbers. But yeah, so this one's been correct. Any comments, leave them down below, and I'll see you guys in the next video. Thank you. Bye.